Here we have a right triangle. This triangle is triangle ABC. Triangle ABC is a right triangle at angle A. So angle A is a right angle. In this video, we will be focusing on the sine, cosine, and tangent of angle C, which we're going to call angle theta. So I like to remember SOHCAHTOA. This is a good way to remember sine, cosine, and tangent. So in SOHCAHTOA, the first letter of every word, the S and the C and the T, stand for sine, cosine, and tangent. The two letters after, in this case in sine, there is an O and an H. The O is the opposite side. So from the perspective of angle C or angle theta, AB would be the opposite side. So this would be the opposite side. The hypotenuse would be BC because it is opposite of the right angle. So this would be the hypotenuse. So the sine would be the length of the opposite side over the length of the hypotenuse. So that would be sine of angle theta. For cosine, we have an A and an H. The A stands for adjacent. The adjacent side would be the side closest to the angle, or adjacent to the angle. Since side AC is right next to angle theta, and it is not the hypotenuse, AC would be the adjacent side. And the H here stands for hypotenuse. So the cosine is equal to the adjacent side over the hypotenuse. So that would be the cosine of angle theta. For the tangent, we have an O and an A. Here, the O would be the opposite side, AB, and the A would be the adjacent side, AC. So the tangent would be the opposite over the adjacent. And these values differ depending on what angle you are looking at. If you're looking at angle C, that the opposite would be AB and the adjacent would be AC. But if you were looking at angle B right here, the opposite would be AC and the adjacent would be AB. So these values differ depending on which angle you are looking at. So this is sine, cosine, and tangent. Now we're going to do some examples. We're going to make another right triangle. This right triangle will have the side lengths of 5, 12, and 13. And if you do the Pythagorean theorem, you're going to find that these lengths satisfy it. So this is going to be the right angle, and we're going to focus on this angle theta. So we could use either sine, cosine, or tangent, but in my opinion, sine would be the easiest one. So we're going to do sine of theta, the sine of the angle theta, is equal to the opposite side, which would be opposite to theta, which would be the 5, over the hypotenuse, which is opposite of the right angle, which would be the 13. So to solve for the measure of the angle, we're going to take the inverse sine of this value. So inverse sine we're going to discuss later on more deeply, but here we're going to discuss it briefly. So the sine of an angle would be the opposite over the hypotenuse. The inverse sine of the opposite over hypotenuse would be the measure of the angle. So if we take the sine of theta and we take the inverse sine of that, the inverse sine and the sine would cancel out just to leave theta. And obviously, we have to do this on both sides. So, theta would be equal to the inverse sine of 5 over 13. And if calculated, we're going to get the value of theta. Now we're going to do another one. So now we're going to make another right triangle. This triangle is going to have the lengths of 3, 4, and 5. And if you do the Pythagorean theorem again, this will work. So this is the right angle, and we're going to be focusing on this angle up here. This we're going to label angle alpha. So we're going to find the measure of angle alpha, and now we're going to use cosine. So again, cosine is the adjacent side over the hypotenuse side. So for angle alpha, the adjacent side would be this side right here, since it isn't the hypotenuse and it is right next to angle alpha. And the hypotenuse would be the longest side, which is opposite of the right angle. So this would be the hypotenuse. So the cosine of angle alpha is equal to the adjacent, which is 3, over the hypotenuse, which is 5. So similarly, we're going to take the inverse cosine. The inverse cosine of the cosine would just cancel it out. So the inverse cosine and the cosine would cancel out. And we obviously have to do this on both sides. So after taking the inverse cosine of both sides, we are going to get angle alpha is equal to the inverse cosine of 3/5. And when you put this into the calculator, you will get the measure of angle alpha.